Welcome to my YouTube channels. Today I am going to discuss the steam table problem by the help of the Mollier diagram. So Mollier diagram method. Steam table method previous video I did. So for this what is given, dry saturated steam at 10 bar is expanded isentropically in the nozzle. Second P2 is given 0.5 bar. And using the steam table method we did this. What we did here, from steam table directly we taken H1 equal to Hg. So this value taken from the steam table. Then S1 equal to Sg is taken, because we know steam suppose expand isentropically, so entropy will be equal. So S1 equal to S2. So once we are finding the H2, it will be wet conditions. Wet conditions now will be the below the saturation line. Red color is saturation line. So that we have to go with the help of the formula H2 is equal to HF2 plus X2 HFG2. So but here X2 we don't have. So X2 means we have to use this concept S1 equal to X2. Entropy will be constant when steam expand isentropically. So this is the entropy formula. I got X2 and substituted here X2, we got the H2. Then velocity of the exit 44.72 H1 minus H2, we calculated this velocity. Now if we'll go the Mollier diagram method, what will we see? The Mollier diagram first. So this is a Mollier diagram. This vertical part is enthalpy. This is the enthalpy, this is the entropy. This will be the entropy. This red color is saturation line. This line, dryness fractions will be 1. Below this, less than 1. Dryness fractions will be less than 1. Above the red color line, that is called superheated condition. So here temperature will be there. If you see, I will show the one glance. So this red color above, temperature will be there. That means it's superheated steam. So now this questions, they given dry saturated steam at 10 bar. So 10 bar will take from the as a saturation line, 10 bar. Here top line also will be, here also pressure will be there. So here pressure and all very complicated will be there, very close value will be there. So you have to bring from here 10 bar and you mark here 10 bar. Mark 10 bar and draw the horizontal line. If you will see this chart, you will get the value for the H1. Again, already given what is steam expand isentropically, that means this entropy will be constant. See here, if will come the vertical line, entropy will be constant. Entropy will be constant. So now again P2 they given 0.1 bar. Again this 0.1 bar in this saturation line, 0.1 bar will be there. So we'll draw the line like arc line, all the pressure line like this will be there. And where will be the joint this line? Again draw the horizontal line, you will get the H2. Now dryness fractions line, like this all the lines will be there. This is also dryness fraction line x equal to 1. With respect to lot of curve will be there. With respect to lot of curves will be there. This curve and all, what is this one? Dryness fraction. So dryness fractions, we'll see how much will be there, we'll write here. And we'll substitute the formula for V2 is equal to 44.72 H1 minus H2. Dryness fraction directly will find now. This will be, they're asking now, find the dryness fraction. So directly X2 will be the answer. And H1, H2, once we'll get substitute the V2, we'll get the answer. So steam table method, we need the formula, Mollier diagram, this graph should be there. This Mollier diagram graph, you have to draw in your answer sheet. I will show the one glance of the Mollier diagrams here. It will look a little. Now see this red color line first you see. So see this red color line. This red color line, this red color line, this is the saturation line. This is the saturation line. Here all the line pressure will be there. All the line pressure will be there. And respective, suppose you will see this line, here pressure will be there in this line. So you have to bring the pressure line from there, because here full close value will be there. All the pressure will be close value will be there. So you have to bring the pressure 10 bar and you have to mark this point. So mark this point. Then you draw the horizontal line. Draw the horizontal, because this is the enthalpy line, this is the entropy line. Draw the horizontal line, will come the 2775. But here what is there? 2776. This is the exact method. Steam table method is known as exact method. This will be the approximate method. How you will see now? You will see this this chart. You will see. Suppose you are taking here 3000, 3100. In between this 10 box will be there. In between this 10 box will be there. Each box contains 10. So suppose you will draw the horizontal line, 4 and 4.5 box. That means 45. 5 box 50, like this you have to consider. So you will get the H1, then again 0.1 bar you will get the H2, that also will get 2029. 2090. So this is student to student, it will vary. This is called approximate method. So if you are the very expert, you will see the values and all very close, then you can get more than closure value of this. But this much fluctuations allowed. Now dryness fractions line. Already I told this line is saturation line. Dryness fraction is 1. With respect to this line, lot of line will be there. Dryness fractions here 1, here 90, 80, 70 like this. So here also 5 line will be there. Suppose 80 is there na, 81, 82, 83, 84, 85 like this will be there. So based on this we can calculate here also this coming for, we already saw na coming 0.793 coming approximately. Suppose some students will get 794, 792, 791, that also correct only. 2775, 27, someone will get 72. But actually what is happening now, here I told lot of box will be there, 10 box will be there. Suppose your line is coming here, then you will see the half line or 1 or 2, it will be difficult to judge exact value. So half means each box contain 10, so 5. Suppose little high, little low, you can take 4, you can take 3. So like 74, 73. So like this we can take the close value. So Mollier diagram, if you'll see, always use the color Mollier diagram. So all the value will be there, enthalpy value. So this all lines will be the dryness fractions line. Above this line will be the superheated condition. Suppose pressure they will give 10 bar and 200 degrees Celsius. Then this value will be different. Here temperature line will be there. That will again superheated problem. I will show the next video. So again line will be here. So once this will join here, if vertical horizontal line will draw, you will get the H1 there. So that will be different video I will explain. So particular this problem, if they are asking the Mollier diagram, suppose this is convergent nozzle only. So P1 and P2 be there. Suppose convergent divergent nozzle P3. So again another pressures will be there. Then again dryness fractions will be there. And Mollier diagram, this diagram has to be in your answer sheet. H1, H2 directly you got. Directly you write the again formula V2 equal to 44.72. Just 1 minute. This also how much answer is coming for us. We are writing now. So they're asking, what they're asking? Dryness fraction. So X2. So X2, this is our answer. First answer 0.793 by the Mollier diagram method. Then directly we'll write the formula 44.72 H1 minus H2. H1 minus H2. So 44.72 H1 will be 2775 minus 2090. So directly you will get V2. In this method V2 you will get 1170.44 meter per second. 44 meter per second. This will be the answer. This also will be the answer. Here Steam table method 0.791. Here 793. Here getting 1170, 1176. This much fluctuations will be there. If what I told, if you'll see the exact very close, keep the scale and see this close value, then you may get here to 72, 73, 91, 89, 88 like this value na, it will come more closer. But this much fluctuation is allowed. So this is the Mollier diagram method. This is the Steam table method. This is small problem I taken. Suppose convergent divergent problem you will take na, it will get 3 value. But if you will go the formula Steam table method, it will go very long. It will go long like 3 convergent divergent told na, H1, H2, then again H2, then again H3, again we have to find the S3. So it will go long. Both are very interesting problems. But Mollier diagram method, if you understand this graphical representation, it will be very easy, very useful for you. Okay? Okay, students, watch this video carefully. Practice the Mollier diagram, color Mollier diagram. And what I did here, that you just watch and see. And practice this Mollier diagram once, you can solve any type of questions. Okay? Okay, students, thank you.